Utility and indifference curves. An indifference curve consists of all those bundles that correspond to a particular utility measure. If Lisa's utility function is capital U of q sub 1 and q sub 2, then the expression for one of her indifference curves is capital U bar equals capital U of and q sub 1 and q sub 2. Equation 3.1. This expression determines all those bundles of q sub 1 and q sub 2 that give her capital U bar utils of pleasure. For example, if her utility function is capital U equals the square root of q sub 1 and q sub 1, q sub 2, then the indifference curve 4 equals capital U bar equals the square root of q sub 1, q sub 2, includes any q sub 1 and q sub 2 bundles such that q sub 1 times q sub 2 equals 16, including the bundles open parentheses 4 times 4, 2 and 8, 8 and 2, 1 and 16, and 16 and 1. A three-dimensional diagram, figure 3.3, shows how Lisa's utility varies with the amount of pizza, q sub 1, and burritos, q sub 2, that she consumes. Panel A shows this relationship from a straight ahead view, while panel B shows the same relation looking at it from one side. The figure measures q sub 1 on one axis on the floor of the diagram, q sub 2 on the other axis on the floor of the diagram, and capital U of q sub 1 and q sub 2 on the vertical axis. For example, in the figure, bundle A lies on the floor of the diagram and contains 2 pizzas and 2 burritos. And directly above it on the utility surface or hill of happiness is a point labeled capital U of 2 and 2. The vertical height of this point shows how much utility Lisa gets from consuming bundle A in the figure. Capital U of q sub 1 and q sub 2 equals the square root of q sub 1, q sub 2. So this height is capital U of 2 and 2, which equals the square root of 2 times 2, which equals 2. Because she prefers more to less, her utility rises from q sub 1 increases. Restarting the sentence, because she prefers more to less, her utility rises as q sub 1 increases, q sub 2 increases, or both goods increase. That is, utility's hill of happiness rises as she consumes more of either or both goods. What is the relationship between Lisa's utility function and one of her indifference curves? Those combinations, q sub 1 and q sub 2, that give Lisa a particular level of utility. Imagine that the hill of happiness is made of clay. If you cut the heel at a particular level of utility, the height corresponding to bundle A, capital U of 2 and 2 equals 2, you get a smaller hill above the cut. The bottom edge of this hill, the edge where you cut, is the curve capital I star. Now suppose that you lower that smaller hill straight down onto the floor and trace the outside edge of the smaller hill. The outer edge of the heel on the two-dimensional floor is indifference curve capital I, making other parallel cuts in the hill of happiness, placing the smaller hills on the floor and tracing their outside edges. You can obtain a map of indifference curves on which each indifference curve reflects a different level of utility. Figure 3.3, the relationship between the utility function and indifference curves. Both panels A and B show Lisa's utility, capital U of Q sub 1 and Q sub 2, as a function of the amount of pizza Q sub 1 and burritos Q sub 2 that she consumes. The figure measures Q sub 1 along one axis on the floor of the diagram and Q sub 2 along the other axis on the floor. Utility is measured on the vertical axis as Q sub 1, Q sub 2, or both increase. She has more utility. She is on a higher point on the diagram. If we take all the points, the curve capital I star that are at a given height, given level of utility on the utility surface, and project those points down onto the floor of the diagram, we obtain the indifference curve capital I. Panel A has, it's a 3-axis graph. The axes are Q sub 1, Q sub 2, and the third axis is capital U of Q sub 1 and Q sub 2, which is the utility of Q sub 1 and Q sub 2. Panel B is the same graph from a different angle. We still have the axes Q sub 2 and Q sub 1 and the utility of Q sub 1 and Q sub 2. Study these graphs, they're interesting.